Okay, we're going to problem solving using plane. They've given us an equation of a plane here, which is some point on the plane represented by our two directional vectors. That's what our plane is. And the plane, they want us to find when the plane is going to intersect the z-axis. Okay. So, one thing we know, the z-axis is essentially where? Anyone know? Should have a coordinate for the z-axis. What is it?
0, 0.
Yeah, we have a, well, the one will give us a unit vector, but we know that we're going to be looking at when x is 0 and y is 0, we'll have some point of z. Okay. Now, that means it could cut directly at that point, or we might be looking at something that is parallel to the z-axis and cuts it at every point. But let's find out what this vector essentially does. Now, we talked about this earlier today. We actually did a question where we're doing a line intersecting the z-axis. This time we have a plane. What we did with the line is we turned it into our parametric form. So we're going to take this equation and put it into parametric form again. So x is equal to 6 plus s plus 2t. Y is equal to negative 2 plus 3s plus 2t. And z is equal to negative 3 minus t. Okay. Now, in the other question, we did turn our parametric form into something else. Does anyone remember? We turned it into symmetric form. But there are no symmetric forms for planes. Okay? So we're going to have to work through it in parametric form. Our z-axis has coordinates of x, y, and some form of z. We don't know exactly what it is. What we're going to do is plug in our values of x at 0, y at 0, and z will stay the same. When we do that, we'll then have two equations and two variables, s and t. We'll solve for s and t and see if they, or what they give us for our z, to find out where it's going to interact with our z-axis. So, 0 is equal to 6 plus s plus 2t. This is our equation 1. We've just shoved it over here. So in this case, that means s is equal to negative 6 minus 2t is equal to s. We're going to take that and we're going to look at equation y and plug that in for our s value in equation y. So 2. Again, y was equal to 0 in that case. Negative 2 plus 3. We replace our s with negative 6 minus 2t plus 2t. This will give us 1. 0 is equal to positive 1 minus, oh, what am I saying? Distributive property. Negative 2 minus 18 minus 6t plus 2t. This will become negative 20 when we move it to the other side. Becomes positive 20 is equal to negative 4t. T equals negative 5. So we have a value for t. We can now take that and put it into our equation 1 again if we like to find a value for s to see if it holds true. And then we're going to plug it into our third equation to make sure that we can find out what our z point will be. Now, technically, because our third equation only has the variable t, we can jump forward. Because there's no s variable in here, we don't actually have to solve for s. But let's say that we did have a question where it was looking for both variables. We would have to solve for our s variable. And we'll do that quickly just so you know the steps to it. Once we have t, we go back into equation 1. 0 is equal to 6 plus s plus 2 times negative 5 gives us negative 10. We move them to the other side. That's negative 6 plus 10 equals s. S is equal to 4. Okay. So that would give us that. We would now have two variables, and we move into our third one, where we're still trying to find z is equal to negative 3 minus, and in this one it's just negative 5. Negative 3 plus 5, z equals 2. So this plane interacts with the z-axis at 0, 0, and 2.